Okay, so in this lesson, we're going to look at our continuing study on the basic concepts of functions, but for this particular lesson, we're interested in evaluating functions. Now, before we can talk about evaluating functions, we need to kind of mention the idea of function notation. So I just want to take a few moments and discuss what function notation looks like. Okay, so you all agree that beginning of the course and even last semester you learned how to graph lines. And so this is a graph of this line here, y equals negative 2/3 x plus 5. And so we also know that based on what we learned in the previous lesson, that we can use the vertical line test, and we can see that this line, this graph, represents a function. So this equation, here's the graph of the equation. We notice that it passes a vertical line test, meaning that for each x coordinate, there's only one y coordinate. So when x is 2, there's only one y coordinate. When x is 3, there's only one y coordinate, and so on. Okay? So this is a function. Rather than naming the equation y equals negative 2x plus 5, since this is a function, we tend to replace y with function notation called f of x. So this y becomes f of x. Now that's how you read it. You read it as f of x. That's not multiplication. That doesn't mean f times x. That means f of x. So this y we can rewrite as f of x since that's a function. So the idea of f being function. So function notation. So we have negative 2/3 x plus 5. So that's another way of rewriting this equation using function notation. All right, so let me just say this real quick. So we know that the equation y equals the one we just talked about, 2/3 x plus 5 is a function, right? Is a function. So we can use function notation. And basically what we do is we replace y with function notation. So that means something like this. Y would replace y as f of x. So this means f of x. That's not multiplication, So keep that in mind. We don't always have to use f. We could say y equals g of x. We can say y equals h of x, and so on. Y equals k of x, anything like that. It could be lowercase letters. It could be uppercase letters. You'll see that in many situations, okay? But those are all different ways of writing function notation. So when we saw this right here, we remembered that this was a function because for each x coordinate, there's only one y coordinate, right? And so instead of saying the equation y equals negative 2x plus 5, I can rewrite it as f of x. The same thing here. See this right here? This parabola, here's the equation of this parabola. That's the equation of this parabola. And remember, it passes a vertical line test. So meaning that for each x coordinate, there's only one y coordinate. So when x is negative 5, there's only one y coordinate. When x is 1, let's say, there's only one y coordinate. When x is negative 2.3, there's only one y coordinate. Okay, so that's a function. It passes the vertical line test. Based on what we just did, though, we now know, hey, since this is a function, I can use function notation. So in other words, I can say g of x is equal to x squared plus 4x plus 1. So that's just different ways of writing the equation. Since that's a function, I can use function notation. Okay? So that's the idea about function notation. Now, let me kind of talk about this objective though. So how are we going to use function notation with our objective? In other words, let's look at this example. example. And I'm going to go ahead, by the way, and use kind of the example we did with this line. I'm going to go ahead and use this right here, and because I want to use this graph to kind of explain something. So let's look at this example. Suppose that f of x was equal to negative 2/3 x plus 5. All right. And so when you evaluate a function, you're talking about something like this. I'm going to talk about the easy kind first. So something like this. Evaluate the following. So letter A, let's go ahead and evaluate f of 0. All right, now listen to what this means. This means, now remember, f of x took the place of y, right? Okay, so f of x took the place of y. Now remember, this says f of x, but in this case, x is 0, correct? All right, so what this means is this. This means find the value of y when x is 0. That's what that means. Remember, f of x took the place of y. So find the value of y when x is 0. So basically what you're going to do is in place of x, you're going to substitute what you see here, 0. So this becomes, so f of 0 becomes negative 2/3 times 0 plus 5. Negative 2/3 times 0, 0. 0 plus 5 is 5. All right. And so your answer, you're going to say this. You're going to say f of 0 is 5. That's all you say. Now there's your work. So if you ask to do the work, this is what you do, but that's your answer. F of 0 equals 5. Now let me tell you what that means in terms of the graph. Okay, so that means this. When x is 0, that means your y value is what? 5. So watch. 0, 5's right here, right? In that 0, 5? Okay. Let's do another one, B. Let's find f of, let's say, 3. F of 3. All right, so remember what that means. This means find the value of y when x equals 3. Now, at some point, most students, kind of in their mind, they know that that's what this means, but basically what you're going to do for the work is in place of the variable x, you're going to substitute 3. Because remember, this says f of x, and x is 3. So you're going to say negative 2/3 times 3 plus 5. The 3's divide out, so you get negative 2 plus 5, which is 3. All right, so f of 3 is equal to 3. There's your answer. This is the answer. And so what that means is this. When the x coordinate is 3, the y coordinate is 3 as well, right? So in that what you see here, look, 3, 3. So this is the point, 3, 3. All right? So make a connection. It's important that you make a connection between these things and in terms of the graphs. So basically what you're finding are points on this graph. That's basically what you're finding. All right. And so instead of using a t-table like we would normally do, we'd say, you see how I found x of, when I asked you to find f of 0? So basically you're saying when x is 0, you're finding the y value. So you go back up here to this one. And so you'd say negative 2 times, negative 2/3 times 0 plus 5. And then so that's 0. 0 plus 5 is 5. You see, you made the connection. This right here is this right here. The same thing. Okay? Except we're using function notation. And then let's do one more with that one. And so in letter C, let's suppose I had this for letter C. Let's suppose I had f of negative 6. F of negative 6. So basically, actually I'm going to do one more. So f of negative 6, you're going to say negative 2/3 times negative 6 plus 5. And so negative 2, 6, negative 2/3 rather. So divide, reduce, I get negative 2 right here. So negative 2 times a negative 2 is 4. 4 plus 5 is 9. So we found that f of negative 6 is equal to 9. In terms of the graph, let me just tell you what that means. When x is negative 6, my y value is 9. So here's negative 6, 9. So the graph, if you continue the graph, it would go through this point. That's basically what you found. Okay? Let's do D. I want to do D because I need to make sure you understand that you're not always going to get nice numbers like we have here, where f of negative 6 was a nice number 9. F of 3 was a nice number 3, and so on. So let's do this one. So let's find f of, let's say, 4. F of 4. So basically, to find f of 4, so remember this was our function, f of x equal negative 2/3 x plus 5. So where we see the variable x, I'm going to substitute 4. Okay, so I get equals negative 2/3 times 4 plus 5. Now, it cannot reduce, but negative 2 times 4 is 8, negative 8, so I get negative 8/3 plus 5. And guys, just use your calculator. If you can't remember, hopefully you do, but if you can't remember how to how to uh, add fractions with unlike denominators, then just use your calculator. Okay, so when you use your calculator, you just say negative 8/3 rather. All right, so negative 8/3 plus 5 equal, and then just change it to a fraction. So in my calculator, I've got to do this. Oops, wrong one, sorry. So let's do it again. Negative 8/3 plus 5. Okay, on my calculator, I got to do this. So second P or B right here. And I forgot to, okay, so what's what? 2 and 1/3? So 2 and 1/3? So this becomes, now remember 2 and 1/3, by the way, remember as a mixed number, I'm sorry, as an improper fraction, is 3 times 2 is 6, 6 plus 1 is 7, so you get 7/3. Okay? Oops, 7/3, positive 7/3. All right, so that was letter D. Okay, let's look at another problem. So let's look at number 2. Number 2. Suppose my function's this. Suppose my function is g of x is equal to 3x plus 4. 3x plus 4. All right, now, most students can handle pretty easily, most students can handle something like this, where you're evaluating at a number. Most students can handle that. Almost all students can handle that. You're evaluating at a number. So basically, where we see the variable x, you're going to substitute negative 5. So I get 3 times negative 5 plus 4, and then you use your order of operations. 3 times negative 5 is negative 15. Negative 15 plus 4 is negative 11. So what we found was that g of negative 5 is equal to negative 11. All right? But it's not always going to be evaluated at a number. So let's say we had this instead. So let's say we want to find g of, let's say, y. G of y. Okay, so now we're going to start, and this is going to be important. Now we're going to start using variable expressions that we're going to substitute. So if I want to find g of y, it's the same idea, isn't it? Wherever, let me go ahead and rewrite this over. Wherever I see the variable, I'm going to substitute this right there. That's inside the parentheses. So this becomes 3, and remember, x becomes y now, 3y plus 4. And I guess I shouldn't use the y because we represented g of x as y. But that's the idea, okay? So let's do another. Let's say g of p. Let me do g of p. So same thing. So wherever you see the variable x, what are you going to substitute? You can substitute p. So I get 3p plus 4. And there's nothing else you can do with this. See how I was able to use the order of operations and come up with a nice number? I can't do that here. That's a variable expression. So you're done. That's the answer. Okay, this is the answer. You are done. Okay, let's look at D. All right, D. Suppose I want to find g of x plus 1. All right, now, again, let me go ahead and rewrite this over. So g of x is equal to 3x plus 4. Now, this is where you got to start being careful. G of x is 3x plus 4. So wherever you see the variable x, you're going to substitute what's inside this parentheses. That's what that means, okay? So then this becomes 3 times, notice I'm putting that in parentheses, 3 times x. I'm going to replace x with x plus 1. Because remember, all of this is being multiplied by 3. And then whatever that is, I'm going to add 4. Now what I want you to do is to simplify this as much as possible. We all know how to distribute. So I get 3x plus 3 plus 4, and so the answer is 3x plus 7. So therefore, you're going to say g of x plus 1 is equal to 3x plus 7. Okay, let's look at another one. Suppose number 3, I have this function. I have h of x is negative 4x minus 2. Negative 4x minus 2. And let's suppose I want to find h of c. H of c. So remember what that means. That means I go to my function h, and wherever I see the variable x, I'm going to substitute c. So this becomes negative 4 times c minus 2, and that's it. You can't do anything else. That's your answer. You can't combine these. You can't simplify this. You're done. B. Suppose I want to find h of x minus 1, let's say. So wherever I see the variable x, I'm going to substitute x minus 1. All right, so this becomes negative 4, in parentheses, x minus 1, and then minus 2. So look, wherever you see the variable x, you're going to substitute this. So negative 4 times what's inside this parentheses, x minus 1, and then minus 2. You see it? Negative 4. This is what I substituted, minus 2. Now let's go ahead and get rid of the parentheses. So I get negative 4x, negative 4 times negative 1 is plus 4, and then minus 2. And then combine like terms, I get negative 4x, a positive 4 minus 2 is a positive 2. So that is h of x minus 1. So there's your answer. All right, letter C. Suppose I had this. Suppose I had I want to find h of 2x minus 3 instead. H of 2x minus 3. Same idea. All you do, I'm going to go ahead and rewrite the function. This is my function. So wherever I see the variable x, I'm going to substitute what's inside the parentheses. See, notice I'm drawing arrows to it. So this becomes, equal, you're going to say negative 4 times x becomes this now, and then minus 2. Okay? And now I'm going to distribute. So I get negative 8x. Negative 4 times 2x is negative 8x. A negative 4 times a negative 3 is a positive 12, and then minus 2. And so I get negative 8x, 12, and a negative 2 is 10. And so therefore your answer, you're going to say h of 2x minus 3 is negative 8x plus 10. All right, let's look at D. Suppose D was this. Suppose for D, you want to find h of, let's say, 6 minus 3x. H of 6 minus 3x. So again, let's rewrite the function. H of x is negative 4x minus 2. So in place of this x, you're going to substitute 6 minus 3x. So this becomes negative 4. Now remember that parentheses is important because, see, right here I didn't have a parentheses because that was just a monomial. But I'm substituting a binomial into this monomial. So you need that parentheses there because all of this has to be multiplied by negative 4. So negative 4 times what I'm going to substitute, and then minus 2. Don't forget to subtract 2. Now let's go ahead and get rid of the parentheses. So I have negative 4 times 6 is negative 24. Negative 4 times a negative 3x is a positive 12x, and then minus 2. Combine like terms, I get 12x. A negative 24 and a negative 2 is a negative 26. So your answer is going to be h of 6 minus 3x is equal to 12x minus 26. All right. Okay, let's do someone with quadratics. So let's look at number 4. Suppose number 4 I had h of x is equal to 2x squared minus 3x plus 1. So h of x equals 2x squared minus 3x plus 1. All right. So let's go ahead and say, so what if a was h of negative 3? So we'll find h of negative 3. Remember, that's the easy kind for students because you're substituting just a number. So wherever you see the variable x, you're going to substitute negative 3. So see, this time I see it twice. Okay, so this becomes 2 times, you're going to substitute what's inside this parentheses. So see where that arrow is pointing? Think of that as substituting this. So in your mind, you're going to say, I'm substituting negative 3, but I'm going to square. Minus 3 times I'm substituting negative 3, and then plus 1. So see, all these correspond. So always think like that. Always look at that, and it helps if you align stuff for some of you. Now let's go ahead and use the order of operations. I'm going to square first. A negative 3 times a negative 3 is 9. 9 times 2 is 18. A negative 3 times a negative 3 is a positive 9. and then plus 1. And then combining like terms, 18 plus 9 plus 1, so that's 10 plus 18, which is 28. So h of negative 3 equals 28. B, all right, now listen carefully to this. This is where it's going to start getting a little bit more hairy. Suppose I want to find h of x minus 4. H of x minus 4. All right? Well, actually, before I do that, let's make it simple. Let's do B. Let's suppose I want to find h of c. H of c. So just like we did before, where we see the variable x, this is our function. So where we see the variable x, I'm going to substitute c. So you see I see it twice, right? So in your mind, you're saying this, all right? Well, I'm going to get 2 times, I'm substituting c, and squaring it, minus 3 times, I'm substituting c, plus 1. But make this look a little bit better without the parentheses. So this is 2c squared minus 3c plus 1. So your answer, h of c, will be 2c squared minus 3c plus 1. All right, so notice the variable c here, you see the variable c's in over here. Now let's do this one. Okay, c, h of x minus 4. All right, now I'm going to rewrite it because sometimes it helps to rewrite it. And when you rewrite it, sometimes it helps to actually underline this and draw arrows. Okay, so in place of this x, I'm going to substitute x minus 4 in place of these x's. All right, so here's what we get. So watch, do it just like this. You're going to say 2 times the substitution, x minus 4 in parentheses. Don't forget, though, you're squaring that. Minus 3 times the substitution, x minus 4, and then plus 1. All right, now here's where you have some work to do. You cannot leave your answer like this. We expect you to, first of all, distribute here, and we expect you to square this binomial. Okay, so let's talk about that. If I go off to the side and I square this binomial, that means this, right? X minus 4 times x minus 4. So let's go ahead and follow this out. X times x is x squared. The outer is a negative 4x. The inner is a negative 4x. And the last is a positive 16. Negative 4 times negative 4 is a positive 16. Combining like terms, I get x squared. A negative 4x and a negative 4x is a negative 8x plus 16. That part is only this. But don't forget, it's being multiplied by 2. So you got to come back and put this inside this parentheses because it also has to be multiplied by 2. Okay? Here, I'm going to go ahead and distribute now. Negative 3 times x is negative 3x. Negative 3 times a negative 4 is a positive 12, and then plus 1. And now I'm going to go over here and distribute this now. So I get 2x squared. 2 times a negative 8x is a negative 16x. 2 times 16 is a 32. And then minus 3x plus 12 plus 1. And so finally, combining like terms, I get 2x squared. All right, a negative 16x and a negative 3x is a negative 19x. 32, 12 is 44. 44 plus 1 is 45. And so therefore your answer, h of x minus 4, will equal this trinomial. 2x squared minus 19x plus 45. That's what it equals. All right, so let's do another one. Let's use the same function. Let's go ahead and use the same function. Actually, let's do a different function. I'm sorry. Let's do a different function. So let's make this number 5. And let's say number 5 is this. F of x equal negative 3x squared plus 5x. Let's just do that one. All right, and let's suppose in number 5a, you want to find f of, let's say, 6 minus x. F of 6 minus x. All right, so wherever we see the variable x, you're going to substitute this. Okay, that's what you substitute, 6 minus x. So what we have now is this, negative 3 times substitute, so put parentheses because you're substituting a binomial, 6 minus x squared plus 5 times 6 minus x. All right, so notice where we saw the variable x, instead of saying negative 3x squared, you're substituting 6 minus x. Instead of saying plus 5x, you're substituting 5 times 6 minus x. You are expected, by the way, to deal with this. So you got to go off to the side. You have to go off to the side and figure out, well, what is 6 minus x times 6 minus x? So you got to square this binomial first. Well, using a FOIL method, 6 times 6 is 36. The outer is a negative 6x, the inner is a negative 6x, and the last is a positive x squared. Putting this in descending order, I get x squared minus 12x plus 36. That, though, is just this. But remember, that is being multiplied by negative 3. So now you got to say this. You got to say negative 3 times x squared minus 12x plus 36. And then let's go ahead and distribute this. You get plus 30 minus 5x. And so now distributing this, the negative 3, I get negative 3x squared. A negative 3 times a negative 12x is a positive 36x plus 30. Oops, a negative 3 times positive 36 is going to give me a negative 108. So minus 108. And then plus 30 minus 5x. Combining like terms, I get a negative 3x squared. A 36x and a negative 5x is a positive 31x. A negative 108, use your calculator if you need to, so a negative 108 plus 30 will give you negative 78. And that's all you can do. So therefore your answer, you're going to say f of 6 minus x equal this trinomial, negative 3x squared plus 31x minus 78. All right. Okay, let's do B. Let's suppose B was this. Let's suppose B was let's find f of, let's say, 2x minus 3. All right, same thing. So let me go ahead and rewrite the function. So my function was this, f of x equal negative 3x squared plus 5x. So where we see the variable x, I see it twice. This is what you're going to substitute. Okay, so you draw arrows if you need to. Some students do, most students don't, but if you need to, go and do it. So this becomes, so f of 2x minus 3 becomes, see, this is f of x, right? But it's not f of x I want, it's f of 2 minus x. So in place of these x's, if you darken it, so if you need to, darken it, and then notice that what I've highlighted, this is what I'm going to put instead. So I get negative 3 times, in parentheses, 2x minus 3 plus 5 in parentheses, 2x minus 3. So basically whatever I highlighted, those x's, I replace it with this. Okay, you see it? Negative 3x, I forgot to square it, by the way, negative 3x squared, so x became 2x minus 3 plus 5x, and that variable x, I substituted 2x minus 3. Now we have to go off to the side and figure out what 2x minus 3 times itself is. Okay, we got to make sure you do that. So I'm going to go off here and do that. So let me do it right here. 2x minus 3 times 2x minus 3. So if I FOIL, 2x times 2x is 4x squared. The outer is a negative 6x. The inner is a negative 6x. And the last, a negative 3 times a negative 3 is a positive 9. Combine like terms, I get 4x squared. A negative 6x and negative 6x is a negative 12x plus 9. So that is this. But remember, that's being multiplied by negative 3. So I got to say negative 3 times 4x squared minus 12x plus 9. And then let's go ahead and distribute here. So if I do that, I get 10x minus, and that's a negative 3, so that's minus 15. Distributing here, I get negative 3 times 4x squared is a negative 12x squared. A negative 3 times a negative 12x is a positive 36x. A negative 3 times a positive 9 is a negative 27. And then just rewriting all of this over, and then combining like terms, I get negative 12x squared. 36x and 10x is 46x. A negative 27 and a negative 15, if you need your calculator, because some of you have problems with signed numbers, so you just say negative 27 plus a negative 15 gives you negative 42, so minus 42. And so you're going to write your answer, though. Your answer, you're going to say f of 2x minus 3 will equal this right here, negative 12x squared plus 46x minus 42. Okay? All right, I think we are basically done with this. So that's all I wanted to present to you right now in terms of evaluating functions. We're going to do more evaluating functions when we talk about the um, the difference quotient. So we're going to come back and talk about this a little bit more, but you're going to do more with the difference quotient. That's going to be important when you talk about calculus. But let me make sure before we end this that I really went over all I wanted to. Okay, so what we're going to do is, so this was kind of like a part one to the idea of evaluating functions. So I'm going to do a couple more, but let's do that in a part two in a different lesson. So that's going to be the end of this lesson, and then we're going to look at a little bit more of it in another part of our lessons. So that'll be the end of this one.